The topic for the day is testing methods in flexible packaging. Now, when you are talking about testing methods, the results are important while we are designing a new package. The results are important and crucial for R&D and QC team. And most importantly, the results are absolutely critical while deciding the costing of the laminate. There are two fundamental deals while we are designing a package. We should know the properties of packaging materials, and we should know the requirements of the products. Products may be tea packaging, products may be biscuits or cosmetics. We have to optimize between the properties of packaging materials as well as the requirements of products. Now, to fine-tune this, we really need only one thing: accurate testing of laminates. So in this session today, we are going to decode and discuss in details about different testing methods of laminates. The person who is going to share the session today is Mr. Vikram Fotedar. He is Director FES and PAC1 in Dubai. He has spent more than a decade in material testing for polymer and packaging. And he is leading a team of highly proficient engineers and process experts in Dubai and India. He had also designed several test labs across South Asia, Middle East, and Africa. So with this, I would like to request Mr. Vikram to please start his session.
So, thank you very much, Prasanjit, Mike, for putting this together. I would like to start with a short quiz to test our notions on package safety. So let's start up with a warm-up question. So, food wrapped in aluminium foil. How many of you all think this is microwavable? I personally don't think so. How about food heated up in glass or ceramic containers, microwave safe? I think that was fairly easy. Yes, that can be heated. Now, what about plastic lunch boxes with no indication on them on whether they're safe or not? I don't think so. How about styrofoam containers? Again, a big hit with the takeaway business. So a strong no. How about this yogurt tub, a used yogurt tub? Even if we take the kitten out, let me ask you a question. How often have we seen, people working in the kitchen, storing food in old yogurt containers and reheating them in microwaves? I have seen it a lot of times, and I have tried to explain the hazards of doing this. So we hope to look into further detail on all of this during this presentation. Now, let's start with the crossroad that the packaging industry is in at the moment. So 6 months ago, and it has been for a few years, everybody was talking about the circular economy, plastic being bad, and all of the waste that has ended up in the seas. There's no disputing that this is a problem and it has to be addressed. But the focus has shifted in the last 6 months, and it's more about food safety ever since the pandemic began. And as packaging professionals or people involved in the supply chain of packaging, we all must agree that we all have to implement very strong standards on material testing for material involved in packaging to make it more safe. So I would like to create a broad classification of packaging. This is in no way a comprehensive classification. So broadly, there is migration testing, which has overall and specific migration, barrier testing, analytical testing, where there is gas chromatography, which is typically used for measuring residual solvents inside flexible packaging, or Fourier transform in IR spectroscopy and differential scanning calorimetry. Again, both of these are used for detecting the constituents of the packaging. substrate conditioning. So there is no test which is complete without the conditioning of the substrate. What here is where we subject the substrate to the abuse that it faces during the supply chain. So this can be flex durability, temperature or pressure, compression and vibration, scuff, UV, rain, salt spray, etc. Then there is physical testing, which is used to determine the runnability of the packaging material, and finally, to put it all together, the package integrity test. So we start with migration testing. Now, before we get into how migration testing is done, let's speak about the need for migration and how is migration caused. So you have direct migration, which is something all of us have seen as we were growing up in India, when we were eating food from hawkers wrapped in old magazines and newspapers, where the print material was directly in contact with the food and causing migration. Then there is through migration. This is where low molecular weight components of our packaging migrate from within the packaging into the food. There can be set-off migration. This is when print layers migrate onto the surfaces on the opposite side when stacked over each other. And there is gas phase migration, which is accelerated by heat, by the volatilizing and condensation of components from the package. So, the challenges differ depending on the kind of packaging that is used and the contents as well. So when it's dry snacks in general flexible packaging, then, we all test extensively for primary aromatic amines and also for residual solvents inside the package. When it's cereal boxes, just like what we had spoken about at the beginning of the quiz, when there is anything related to paper boards, particularly recycled boards, there can be mineral oil content in the board. And this can, by gas phase migration, move through the liner film and into the cereals. Or it could be also in aseptic cartons, where there have been instances of low molecular weight photoinitiators migrating by set-off migration and coming in contact with the milk. Now the first step in migration testing is to finalize your simulant for the study of the migration. Now, a simulant is a chemical which would emulate the behavior of the food when it comes in contact with the packaging. There are simulants created in standards depending on the food in question. So there are simulants for aqueous foods, for acidic foods, alcoholic foods, dairy fatty foods, non-dairy fatty foods, and dry foods as well. Now, once we have decided on a simulant, then we need a migration cell. A migration cell is where we leave the simulant to interact with the packaging. So in the cell that you can see, there are two layers of film that encapsulate the simulant, and then the migration cell is conditioned over a period of time. This conditioning can depend on the storage conditions, the supply chain conditions, and the usage conditions of the package under consideration. There are again some standards that govern the preparation and conditioning of the migration period. So, as you can see here, these are the EU regulations for overall migration. So depending on whether the product is a frozen food or a long-term storage product, the conditions can differ in terms of conditioning of the migration process. Now, in the end, what we are after is to find out how inert the packaging material is, particularly in the case of overall migration. And every packaging body around the world has its own standards for the limits on how much of overall migration is permissible. Beyond overall migration, we also need to test for specific migration, particularly in the cases of certain heavy metals. This could be like lead, cadmium, selenium, hexavalent chromium, mercury, which were historically present and still sometimes occur in inks, coatings, films, and can increase over a period of time within your body by a mechanism called bioaccumulation, and can cause neurological, intestinal, and renal disorders. Then there is also the phthalates, ketones, toluene, which is present in additives, inks, and organic solvents. These are reprotoxicants. Reprotoxicants are chemicals that are toxic to the reproductive system, particularly in females and particularly in younger children with developing reproductive systems. Then there are the low molecular weight photoinitiators like ITX, which is found in ink, which I had spoken about earlier in the example for milk enfolding in a septic carton. These are endocrine disruptors. Endocrine disruptors are chemicals which mimic the hormones within our body, and they affect the normal functioning of the endocrine system of our body. Then there is, of course, the PFAs and PAAs, which are present in adhesives and coatings, which can be carcinogens and mutagens, causing cancer and various serious illnesses over a period of time. So the population which is most at risk from this is children and expectant mothers. Children because of the lower body weights and formative immune and endocrine systems, and expectant mothers who can have congenital defects in the fetuses or even miscarriages depending on the period of exposure. So the next area that I would like to speak about is barrier testing. Now, barrier testing can be for oxygen barrier, water vapor barrier, or gas barrier. In the first step, we are going to talk about oxygen and gas barrier testing. Now, this is particularly important for doing shelf life studies to understand how long can food be safely stored in pouches before they turn rancid, before they oxidize. So what you can see on the right side is a typical permeation cell. Now, any permeation cell is divided into two chambers, with the substrate or the film that needs to be tested, which lies in between these two chambers and creates this isolation. In the case of the manometric method, what you have is you maintain an atmosphere on one side of the chamber, the upper chamber, and you maintain a vacuum in the lower chamber. And then you measure the time it takes for this vacuum to decay in the lower chamber. This is directly proportional to the transmission rate of the film in question. And we can also analyze the gas mixture which has migrated into the lower chamber by a residual gas analyzer to tell you the constituents of the gases that have migrated. The next method, which is an electric method, is the Coulometric method for oxygen transmission testing. As the name suggests, there is a sensor which produces an electrical signal which is directly proportional to the oxygen that passes over it along with the carrier gas. Again, as you can see, in this illustration, the permeation cell is not placed vertically but horizontally, and you can see that you have on one side the oxygen gas maintained in one of the chambers, and on the other chamber there is the carrier gas, nitrogen, which carries with it any molecules of oxygen that permeate through the film to the other chamber. And this is then passed over the sensor to detect oxygen transmission. These test methods are vitally important for doing your studies on shelf life. Now, another important barrier testing is for water vapor transmission. In water vapor transmission, you have, as the name suggests, a gravimetric method, which can be either by loss of weight or gain in weight. So it is crucibles which are kept in a stable atmospheric condition and stable temperature conditions on very sensitive balances. In the case of the evaporation method, the crucible is filled with a liquid, and in the case of the desiccant method, it is filled with a desiccant. And what one studies is the transmission of the moisture from inside the crucible out to outside in the evaporation method, and in the desiccant method, vice versa, where moisture from outside comes inside the crucible and gets absorbed by the desiccant, and thus the weight increases. And this change in weight is directly proportional to the water vapor transmissibility of the film. Then there are also the electrolytic methods and infrared methods for testing water vapor transmission in packaging. So the infrared method is governed by the Beer-Lambert law, which is when you have light incident on a gas medium, then some of the light gets absorbed or is deflected by the gas medium, and only some of it is allowed to pass on to the other side. So depending on the difference between the intensity of the light, which is incident and emergent, we can calculate the density of the gas, of the moisture that has permeated through the film. And the electrolytic method is a method where the moisture within the carrier gas is passed over glass tubes that are coated with phosphorus pentoxide and wrapped with platinum windings. And as the moisture-laden carrier gas passes over the sensor, the phosphorus pentoxide, it absorbs this moisture, and by absorbing this moisture, it reacts with the platinum windings to create an electrical signal which is directly proportional to the transmission rate of the moisture. Of course, in all of these cases, you have to always keep in mind that there is the permeation cell which is used and the two chambers. So this helps us to understand the level of barrier performance of the various substrates. Now the method selection really depends on the sensitivity required, which again depends on the barrier rate of the film. So for higher barrier films, you would use the electrolytic method, but for lower barrier films, you could, of course, get away with the gravimetric methods. Now, as I mentioned before, no test is complete without adequate material conditioning, because this is the step where you subject the packaged material to all of the effects that it is and abuse that it is subjected to during the supply chain. So you can see a picture here of a Galvoflex tester and a salt spray tester. There are many other material conditioning procedures that are adopted. To give you an example, when you have a structure which has an allox layer or a metallized layer inside it, now an allox layer is very sensitive to and has very low flexural strength. So if we subject it to a Galvoflex movement, then the results would be very different before and after if we do a comparison of the barrier properties. So such kind of applications in combination can help us get very interesting results. Another example could be using accelerated UV exposure on a new laminate that you have produced to check the stability of the laminate in outdoor conditions and the potential migration which is caused due to the exposure to UV rays. Another application of testing is processability and performance testing. There are various tests within this category, which can be coefficient of friction, which is typically used, to see the runnability of the film through the machine. A very high coefficient of friction film would be able to run very slowly through a filling line, or might wander and not be able to hold its parts during the filling process. Then there is tear propagation. This can be another very interesting test, particularly from a usability point of view. We have aging populations, we have children who are accessing packaging, and they do not have the strength that adults have. And we do not want them to be using their teeth or tools to open packaging. To see accessibility of packaging, tear propagation studies can give you a lot of feedback. Hot tack is another very interesting study which helps you determine the speed at which a package can run on a filling line. Tensile strength gives you feedback on the tensile properties and elongation properties of a polymer, and bond strength, and many others. Finally, what brings it all together? So you've done the material conditioning, you've tested the barrier properties, you've tested the inertness by migration studies, you've done everything. But the machine alone, the material alone does not deliver a good package. It's a combination of the material, the machine, and the person who's running the machine. So package integrity testing is another very important test that should be undertaken. To give you an example, a bubble leak tester can very quickly tell you if there are any micro leaks inside a package. This can be very important because small micro leaks can allow micro channeling, which could permit spores of fungi or various pathogens to get into the package and contaminate the package. And sometimes consumers don't always check the package before they consume it, and this can lead to hazardous consequences. Another very important test is leak and seal strength test, which can be carried out in creep mode as well as in burst mode. Now, all of these put together, can give you vital information about the running conditions. Were the sealer jaws maintained properly? Was the pressure in the jaws maintained properly? Was the temperature in the jaws maintained properly? Because in the end, if you have the perfect barrier, you have perfect inertness in the packaging, but the machine was not set up well to run the package, then the package is going to fail. So that brings me to today's challenges, So coming back to the crossroads that we spoke about. So 6 months ago, there was a lot of emphasis on circularity, and that in itself poses a lot of challenges to the packaging supply chain as well as package designers. So first, the PCR, which is being cycled back into food grade packaging at times. We need to determine if that is safe and for consumption. Then the dynamism in the product structures. For decades, the product structures for snack food were reverse printed polyester, metallized polyester and PE all laminated together, or a reverse printed BOPP, laminated to metallized BOPP, which is heat sealable. But now, when circularity norms come into effect, then one has to innovate new structures. And whenever there is a change in status quo, then one needs to be very careful in implementing proper checks and balances on our material testing procedures. Another key aspect that one has to look at is the long-term effects of new materials, because some of these are not entirely known, like the long-term effects of nanocomposites, which are being used to enhance barrier properties of monopolymer structures. Or is paper the answer to everything? And the coatings which offer grease resistance, barrier properties, and heat sealability contain PFAs, which are, as I mentioned before, at times carcinogens and mutagens, and can have long-term hazardous effects on human beings. Then the second area, which is of change which we face today, is COVID-19 and the demands that has brought about, the awareness that has brought about in people. See, the world is never going to be the same. We're going to refer to this as the pre-COVID era and the post-COVID era, and everything needs to change. Our buying habits are changing. Our travel habits are changing. Our consumption habits are changing. And that is all having an effect on packaging. As one can expect, binge purchases have seen an uptick in flexible packaging and grocery products. But at the same time, some packaging applications have taken a beating. So more discretionary spending packaging has been put on hold because of the instability in the job markets. So all of this is having a demand on the packaging industry. So I would like to look at this is a graph that's been prepared by McKinsey, and which explains very well the emphasis 5 years ago, today, and 10 years hence. So sustainability wasn't much spoken about 5 years ago, but it has gained importance recently, and will continue to do so over the next 10 years. E-commerce has has accelerated at breakneck speed, with everybody ordering their groceries and food and other goods online. Then there have been changing customer preferences and consumption habits, as I mentioned before, and people are becoming more conscious about hygiene and health, and also in today's time, more price conscious. At the same time, the FMCG is seeing a compression in their margins because of the supply chain disruptions that have been caused by COVID-19. There is also a trend towards digitalization and more intelligent packaging and adding more information into the packaging. So as we can see, there are a lot of forces at work and which are changing packaging. And what we see today is a very different world from what it would be 10 years hence. And we all need to work together and gear up and be prepared for the future. Overcoming the duality in supply chain, which is safety versus sustainability and pricing. So we need to strike a balance, and everybody needs to think independently and do their own research and development in developing packaging. And we need to break away from our traditional method of Me Too packaging, where everybody is just mimicking what everybody else is doing. Finally, we need to have a safe transition into a circular economy for packaging, and all of this while surviving the coronavirus pandemic. So with this, I would like to finish my presentation and tell you a little bit about myself. I have a global network of partners, and we work in the packaging industry together with brand owners to develop more exciting standards in packaging. In Pack1 Middle East, we're working together with brand owners in primary packaging. In Pack1 Solutions LLP, we help the converting industry by delivering technological solutions. Fotedar Engineering Services in Dubai is an engineering service company based out of Dubai, and Priority Pack is a projects company that implements bag making solutions around the world and trains operators on how to make the best out of them. So thank you very much, Mr. Prasanjit and MyCoolPackaging, for the time, and thank you everybody for listening.